All right, guys, so in this video, it's not required notes by any means, but this is just meant to help you with reviewing the different types of factoring that you would have seen in Algebra 1 and probably used a little bit of in geometry. So we're going to go through kind of the basic types. That way you at least have an idea of kind of how to get started as you start working through those activities that were posted for you on Canvas. So let's start by taking a look at numbers 1 and 2. Just as a hint, let's make sure we're always looking for the GCF first. Now, the GCF stands for the greatest common factor. In other words, what is the largest thing that you can factor from all of the terms in your expressions? In other words, what's the largest thing that they all have in common? So taking a look at number 1, we've got 4x squared plus 28x. And as we look at those two terms, so one term is here, second term is here, we're looking for what is the largest thing that we can divide both of those by. And pretty clearly they're both divisible by 4. They're also both divisible by x. One has x squared, the other has x, so we can factor out a 4x from both of those terms. What we mean by factoring out is that we mean we're dividing out 4x. In other words, if you take 4x squared and divide by 4x, that's just x. And then if you take 28x and divide by 4x, that's just 7. Now, to make sure that you've done this correctly, and I'll show you this, but we don't need to do it every time, if we distribute 4x to both of those terms, we should get back to our original expression. 4x multiplied by x is 4x squared, 4x multiplied by 7 is 28x, and that is in fact the same as our original expression, so we know we factored correctly. So if you ever want to check your work, just multiply it back out, and then you'll know that you got the right answer. Okay, let's do one more example of this. So on number 2, we've got 6k squared minus 54k. Pretty clearly, both 6 and 54 are divisible by 6. Once again, they also have k. So let's factor out 6k. So if we take 6k squared and divide by 6k, we're just left with k. If we take 54k and divide by 6k, we get 9. And since it was a minus 54, we'll leave that as a minus 9. I'll leave it up to you this time to multiply it back out if you'd like to check your final answer. So that's going to be the first thing on each of these problems is we're going to look for a greatest common factor first. And sometimes that'll actually make factoring very easy. Unfortunately, there won't always be a greatest common factor. So let's take a look at number 3. So on number 3, we've got x squared plus 7x plus 10. Now again, we're looking for a greatest common factor first, but between the numbers of 1 in front of x squared, 7 and 10, we can't divide by a number to simplify. Also notice that there's not an x after the 10, so not every term has x in it. And so at this point, we really aren't able to do anything. So here's the way that we're going to factor. We're going to look for numbers that multiply to be the last number and add to be the middle number. So numbers that multiply to be 10, which also add to be a positive 7. Now there's kind of two different ways that you can set this up. One is that you can make a list of all the numbers that multiply to be 10. Pretty short list, just 1 and 10 or 2 and 5. And then look for which combination will multiply or will add to be a positive 7. Pretty clearly that's 2 and 5. Those actually end up being your factors. So x plus 2 and x plus 5 would be your final answer. Once again, to check and make sure we got it right, if we distribute x multiplied by x is x squared, x multiplied by 5 is 5x, 2 multiplied by x is 2x, 2 multiplied by 5 is 10, and if you combine the terms in the middle, x squared plus 7x plus 10, we do in fact get back to our original expression. Now, the other way to factor is to use this diamond setup, where you'll put the number that you multiply to get on top and the number that you add to get on bottom. And then on the two sides, you try to figure out which number pair would work. Once again, that's 2 and 5, and those would be your factors. I mentioned that because I'm going to show that diamond method later on in the video, and so to make sure you're familiar with that, that's what I mean when I set up the diamond. Okay, let's take another look at an example of this. So on number 4, we're going to work it in much the same way. We're going to look for numbers that multiply to be negative 30, which also add to be negative 1. So to be 30, let's just think about 30 itself first, and then we'll kind of figure out the negative part. Our combinations are 1 and 30. We can multiply 2 and 15, 3 and 10, and 5 and 6. Now, keep in mind that at least one of those is going to have to be negative in order to get negative 30. So whether that's negative 1 and positive 30, or positive 1 and negative 30, or negative 2 and positive 15, or 2 and negative 15, and so on. I'll write those out real quick for us. So 3 and negative 10, and then finally we've got negative 5 and 6, or 5 and negative 6. And we're looking for a combination, one of those that we've just listed, that would multiply or would add to be a negative 1. Only one of those combinations is going to add to be negative 1, which is 5 and negative 6. So for our two factors, the way that you'll write that, each one will start with x, then you'll use 5 and a negative 6. Since the 5 is positive, we'll make that a plus 5. Once again, for those that would like to see the diamond, you're looking for numbers that multiply to be negative 30, add to be negative 1, and once again, those numbers end up being 5 and negative 6. Okay. Next, let's take a look at number 5. Now notice that number 5 is a little bit different. You actually start with x to the third power, and we haven't seen that before. If that's the case, what we should probably look to do first is see if there's a greatest common factor. In other words, is there something that all three of these terms have in common that we could divide them all by? In this case, it's not a number, but actually a variable. If you notice, they each have x in them. So we can factor out an x. If we take x to the third and divide by x, that's x squared. 10x squared divided by x is 10x, and 9x divided by x is 9. Once we've done that, we're now going to try to factor what's left in the parentheses. So we'll just kind of keep going like we would in previous problems. In other words, we're looking for numbers that multiply to be 9 and add to be 10. So to multiply to be 9, you've got 1 and 9. You've also got 3 and 3. Only one of those combinations will work to give you a 10, which is 1 and 9. So when you set up your two parentheses, again starting them both with x, you have a positive 1 and a positive 9, and then just don't forget that you still had the x that you factored out at the beginning. All right, number 6 is a special type of factoring. So notice that it looks a little bit different because it's missing its middle term. Anytime it's missing its middle term, you first want to look to see, is there a greatest common factor? And between 9 and 25, you can't divide by the same number, so we're going to have to try something else. And in fact, this is actually a special type of factoring. Notice that 9 is a perfect square, m squared is a perfect square, and 25 is a perfect square. Notice that you also have subtraction. This is a special type of factoring which is known as difference of squares. Whenever you have difference of squares, what you'll do is take square roots of everything. So square root of 9 is 3, square root of m squared is m, square root of 25 is 5. So then to set up your factors, all you have to do, you're going to use 3m and 5 in both parentheses, and then just make one of those a positive, one of those a negative, and you're actually done with factoring. Now, let's just check this one to make sure it works since it's a little bit different. If we take 3m multiplied by 3m, that's 9m. 3m multiplied by negative 5 is a negative 15m. 5 multiplied by 3 is 15m. And 5 multiplied by negative 5 is negative 25. I think I missed the squared on 9m squared, so let me fix that real quick. Notice that your middle two terms then are going to cancel each other out, and so you get 9m squared minus 25, which is in fact the same as the original expression. All right. So let's go ahead and do one more example, and then our last example, we'll work through a few different ways to make sure it makes sense. All right, so number 7, notice that once again, we've got something that's a little bit different. Notice that this time we've got a number in front of n squared. So as we look to factor, first thing we'll want to check and see, is there a greatest common factor? And unlike on number 5, there's not a variable for each of these terms. However, they are all divisible by 2. If you take 2n squared and divide by 2, that's n squared. 16 divided by 2 is 8n, and 30 divided by 2 is 15. Once we've done that, once again, we'll look to simplify our terms. So we're looking for numbers that multiply to be 15 and add to be 8. For 15, you've got two options, which are 1 and 15 or 3 and 5. Pretty clearly, 3 and 5 will work to give us an 8. So once again, for our two parentheses, we'll start them both with n. One of them will become plus 3, the other will become plus 5, and make sure to include the 2 at the beginning. All right, so on number 8, here is the one that's going to be quite a bit different from the other examples, and I'll show you why that is, and then we're going to work through it actually 3 different ways before we're done with this video. So the first thing that I want to point out is, unlike the other problems where you have a number in front or where it's something besides just 1x squared, unfortunately all of our terms are not divisible by 5. In fact, only the first term is divisible by 5. So we're going to have to do something a little bit different for this problem. And actually it all depends on this first step. The first step is you're going to take 5 and multiply by 3. 5 multiplied by 3 is 15. So in the previous problems, we were always looking for numbers that added to be 3, or multiplied to be 3 and added to be 8. We're going to make that a little bit different this time. We're going to look for numbers that multiply to be 15 and add to be 8. So let's think about what those numbers are. So numbers that multiply to be 15, we've got 1 and 15 or 3 and 5. And so to figure out 8, obviously 3 and 5 are going to work. So let's do this first. The first method I'm going to show you is the diamond method. So starting at this point, what we're going to do is set up our diamond. We're going to have 15 on top, 8 on bottom. So remember, that meant that we were multiplying to be 15, adding to be 8. We've actually already picked out those numbers, which are 3 and 5. The step that's going to be different is we're now going to use the 5 that was in front of x squared. In fact, we're going to put 5 above each of those terms. Now what we're going to look to do is we're going to look to see if we can divide on either side of our diamond by the same number. Now pretty clearly, 5 and 3 you can't divide, can't simplify. But on the right side, you have 5 and 5. Both of those are divisible by 5. In fact, if you take 5 and divide by 5 is 1, and 5 divided by 5 is 1. And actually, at this point, we are ready for our final answer. For the first parentheses, we're going to use the 5 first and the 3 second. For the second parentheses, we're going to use the 1 first and then the second one in the second spot. We're then going to make sure x gets attached to each of those, and since it was a positive 3 and positive 1, we'll put plus signs for both. Now, let's go ahead and check real quick to make sure that this worked. Again, we should get back to this original expression, 5x squared plus 8x plus 3. So 5x multiplied by 1x is 5x squared. 5x multiplied by 1 is 5x. 3 multiplied by 1x is 3x. 3 multiplied by 1 is 3. Then let's combine these middle terms. So 5x squared plus 8x plus 3. And we did in fact get our original expression. So we should now know that that method does work to get us the correct answer. So that's the first method, which is the diamond method. Method number 2 is what's called splitting the middle. So here's how splitting the middle is going to work. We're going to start with our original expression, which is 5x squared plus 8x plus 3. We're then going to split this middle term into two numbers. In fact, we're going to split it into the two numbers that we picked right here. So we're going to split that into 3 and 5. So we're going to rewrite 8x as 3x plus 5x. And if you think about it, 3 plus 5 is in fact 8. So we're really not changing anything. We're then going to copy down the rest of the expression. So 5x squared and the 3 will be copied down. Now, splitting the middle means that we're also going to split the middle and split our terms in half. We're then going to look for a greatest common factor on each side. So for 5x squared and 3x, the greatest common factor is just x. We're then going to copy down the 5x and the plus 3 that would be left over after we divide by x. On the right side, 5x and 3, they don't have anything in common. Whenever that's the case, we're just going to put a plus 1. And then if we divide both of those terms by 1, 5x divided by 1 is 5x, 3 divided by 1 is 3. Now, if we've done everything correctly, at this point, these two parentheses should match each other. So what we're going to do then is we're going to factor out that parentheses from our expression. We're going to factor out a 5x plus 3. So if you think about what would happen if you were to factor that out and divide it from the two terms, the only things you'd be left with is an x and a plus 1. That will become your second parentheses. And if you take a look, that is actually the exact same as what we got from method 1. The third method is probably the hardest, at least to start with, because it's not necessarily a surefire way to work things, but it can actually be pretty quick once you've practiced it enough. And it's what's known as guess and check. So by guess and check, here's what you do. You set up your two parentheses. And the first thing you're going to have to think about is that the first two terms have to multiply to be 5x squared. The only way that can happen is to use 5x and x. Next, the next two spots in the parentheses have to multiply to be a 3. The problem is if you use 1 and 3 in this way, you're going to get 5 and 3 multiply to be 15, 1 and x multiply to be 1x, and 15 plus 1 is 26. So that's not going to work. So let's switch the order of those and see if we can get it to work this way. Now if we take 5x and multiply by 1, that's 5x. 3 and multiplied by 1 is 3x. And 3x plus 5x is in fact 8x. So it looks like our two factors should be 5x plus 3 and x plus 1. And actually, once again, if we compare that, that is the exact same thing that we've got the other two methods as well. So depending on which method you like the most, you'll have to decide, would you like to use the diamond method, split in the middle, or guess and check? Every single one of those methods will always work, so it's a matter of personal preference which one you like to use. I hope this gives you a better idea of what we're looking to do in that factoring activity, and this also will be something that we'll continue to use as we get into Unit 4. Until next time, have a great day.